I'm Ethan Kwan, and today I'm going to be teaching you about higher index roots. So, for the rest of our time, or for most of your math, you have used what is known as the square root, or just or what's known as the square root, which is just given by this radical sign. Or actually, some people just do that, but it doesn't really matter. This just implies that you're taking the positive square root, because the square root can vary from positive to negative, but that's all for another video. Let's, for example, take the square root of 9. And I hope you memorized your multiplication table by now. If you haven't, well, you should. So what times what equals 9? Well, this is equal to 3, because 3 times 3 equals 9. So that is our, that is that. Okay, so let's, also you might have heard, but not have used yet, what's called the third root, or the cube root. So let's, for example, take the cube root of 27. Do you know what this means? Well, this means what times, exactly that same what times whatever that first number was, equals 27, or basically what times what equals 27. Well, this is also 3, because, this is 3, stop it, 3, okay, so, because 3 times 3 equals 27, or 3 cubed equals 27, and let me just change colors because it's kind of lame. Okay, anyway, so what we're going to do now is we are going to, let's do one more example, which might be a little complicated to you. Let's try and take, and yes, I changed colors, we're going to try and take the fourth root of, I don't know, let's say 16. So what's the fourth root of 16? Well, this is asking what times what times what times what equals 16. Well, in this case, this is going to be, stop it. 16 is the fourth root of 16 is equal to 2, because 2 times 2 times 2 times 2 times 2 times 2, yeah, no, equals 16. Or 2 to the 4th power equals 16, okay? So that is what that is. Okay, now let's zoom out a little, and let's try something even harder. And this is not going to be a perfect root, so you're going to have to simplify, not solve. What is the 5th root of 96? What is the 5th root of 96? Now, this might be really complicated to you. You're going to say, like, oh my god, I can't solve this. But it's actually pretty simple. Watch this. What we do is we factor this into its parts. So factoring 96, we can factor that into, let's see, 90, 45, 48, 48, correct me if I'm wrong, times 2. Which you can factor into, let's see, 48 can be divided by 2, or actually, let's do it this way. 48 can be divided by 2, what is that, 24, yes, so 24, 2, or we can do this, or we can go straight to 24 from 48, by going 24 times 4. But one of the ways is much more simple, because 4 can be factored into 2 times 2, and that's a prime, so it can't be factored anymore. 24 can be factored into, let's see, 12 and 2, which can be factored into 6 times 2, which can be factored into 3 times 2. This is what we do. Okay, so now let's count up all the repeating digits, or the bottom digits. So here are all the last numbers. So we have 5 2's. So 96 is equal to 2 times 2 times 2 times 2 times 2 times 3. You can check that if you want. 2 times 2 times 2 times 2 times 2 times 3. 96, yes. Yeah, so there are 5 2's. Okay, that's a lot of 2's. Okay, so what we're going to do now is we are going to put all these together. So you can do this as 2 to the 5 times 3, right? Because there are 5 2's getting multiplied together. So it's 2 to the 5, right? Okay, times 3, of course, because there's this last little kind of outlier 3 here. So this is what 96 is equal to, but we don't want to find what 96 is equal to. We want to find the 5th root of 96. So we're going to take 2 to the 5 times 3. 2 to the 5 times, switch colors, this is the hard part, times 3. And then we're going to put that under the radical. So let's put that under the radical. Let's put that under the radical. 5th root of 2 to the 5, 2 to the, I guess I should use the same color. 2 to the 5, that's not the same color, but I don't care anymore. 2 to the 5, that's kind of small, too big, 2 to the 5 times 3. Okay, colors. 2 to the 5 times 3. Again, it's not the same color, but I didn't find the exact color. Sorry. Okay, so 2 to the 5 times 3. The 5th root of 2 to the 5 times 3. Well, this can be turned into the 5th root of, I think that's a little small. 5th root of 2 to the 5, 5th root, times the 5th root of 3. Now, why does this matter? Well, as you can see here, there's a 2 to the 5 and there's a 5th root. Well, how does this simplify? Well, you can see that this simplifies into just 2, because the 5 here and the 2 to the 5 here cancels. So you're just left with 2 times the 5th root of 3. 5th root. Now, this is as simplified as we can get it, but we can write it in standard notation by putting it as 2 times the 5th root of 3. Yeah, we don't put the dot in between, because if numbers are right next to each other, that means multiplication. Not that this means multiplication, of course, but anyway. Okay, so we don't know the 5th root of 3, and honestly, we don't care. We just want to simplify. Okay, so let's do one more, and this is going to be the hardest one of all. Let's try and find the 6th root. Let's try and find the 6th root of, why is it so big? 64x to the 8th. How do we simplify this? Well, again, 64 is not a perfect, is it? I think it is, actually. Never mind. Anyway, 64 is, okay, so let's factor 64 first. So 64 equals, time to factor, let's see, 64 is 32 times 2, which is, how can we factor that? 16 times 2, which is 8 times 2, which is 4 times 2. I think you know, see where this is going, which is 2 times 2. 2 times 2. So now let's count up how many 2's we have. Let's circle them, actually. So let's circle all the bottom numbers. So everything I'm just highlighting. These are all 2's. How many 2's do we have? 1, 2, 3, 4, 5, 6. Okay, so we have 64 is equal to 2 to the 6th. Now that simplifies things a mighty bit because we can just grab, what's that? What happened there? How did this become here? Anyway, so this is just going to be 2 to the 6th. No, not 26. 2 to the 6th. X to the 8th, right? And we take the 6th root of this. Now we can simplify this by putting a dotted line between here and simplifying this as 6th root of 2 to the 6th times, that looks 2 to the G, that looks like 26 actually, 2 to the 6th times x to the 8th. And actually it would be the 6th root of x to the 8th, sorry. 6th root of x to the 8th, right? So what is 6th root of 2 to the 6th? Well, the 6's cancel out like this, and you're just left with 2, right? That simplifies things a lot because now we can just let's do something else now. Let's just write that down. So now you have 2 times the 6th root of x to the 8th. Actually, you know what? There's a way to simplify this even more. We can simplify x to the 8th as x to the 2 times, not y to the 2, x to the 2 times x to the 6th, because same basis, you can just multiply 2 to the 6th. 2 times 6 is 8. 2 plus 6 is 8, so you get 8. So this is exactly the same thing. Now we can put them each under their separate radicals. Let's put 2 there so we don't forget. 2 times x to the 2x times x to the 6th. Now this is just the same thing as x to the 8th. Don't worry, I haven't changed things up. Okay, so now let's put each of them under their separate radicals like this. 2, let's switch colors, I haven't in a while. Okay, so we have 2 times, and let's swap the order just for fun. X to the 6th, actually this would be the 6th root. 6th root of x to the 6th times the 6th root of x to the 2. Now, look at this. This is awesome. I love things when things work out. The 6's cancel out and you're left with 2x times the 6th root of x squared. Now, don't you just love it when things work out? Okay, but there's a way to simplify this even more. Can you pause the video and think about it right now? Okay, so I hope you thought about it. If you haven't, please pause the video right now and think about it. Okay, I hope you did. Here's the answer. As you might know, that if you have a random radical, let's call it n. So the nth root of, I don't know, x, that can be simplified into x, whatever x is, to the 1 over n. Okay? So that is a property of radicals. And if you don't know, or actually it should be roots. So nth root. So any root can be translated like that. So let's do that with x squared here. And let me just switch colors just because, okay? Don't judge. Okay, so n, blah, blah, blah. Okay, so this can be equal to 2x times the 6th root, and actually I'm not going to do that. I'm going to put brackets here so that we can just use this definition here, this definition right here. What's x? Well, that's x squared. So we're going to put in brackets x squared, and then we're going to put that to the 1/6 power. Now, there's another property of exponents that you might know, that if you have 2 to the 1/6, or actually it should be x, whatever x is, to the, I don't know, to the x, that wouldn't work, would it? Let's do a, just for fun. A, nah, let's do b. Sorry, I'm just switching randomly. A little bit lower, b. Okay, so b, if you have b to the x, to the y, that's the same thing as b to the x times y. So let's do that here. Let's do that with this here. Okay, so if we do that, we get x to the 2 times 1/6, and, oops, no, not 16, 1/6, right? And 2 times 1/6 is equal to 1/3, right? So x to the 1/3, and let me just write down the 2x so I don't forget. 2x times, and since we did the math right here, times x to the 1/3. Let me just put this in brackets. Okay, there we go. So that is one of the most simplified versions of this. Now what we can do is we can put that in standard radical form. We can just use this law right here. This law, but we can reverse it, right? If we do that, we can just, well, if we do that, we can just take, if x to the 1/3 is going to be equal to the cube root of x, right? So if we do that, this is equal to, and drum roll please, and since we simplified that awesome thing, 2x, why is it so huge again, times the cube root, I guess I should do that in a different color, times the cube root, keep drumming, times the cube root of x. So that is the most simplified version, and let's look at what we came up with. What was the original? It was 64, the 6th root of 64. Okay, so look at the difference. The 6th, here's the original. The 6th root of 64, oops, no, that's not what I need to do. No. I'll just redo everything. Okay, the 6th root of 64 x to the 8th. Look at that! Look at that complicated equation, and we can always make it bigger. Let's do that. Okay, so the 6th root, drum roll please, the 6th root of 64 x to the 8th. That was our original equation. Look at how much it simplified. Wow! Great job, you guys. I hope you liked this video. If you did, please subscribe. Hit that like button, subscribe, and remember to share this channel with other people. If you also liked it, please hit that thumbs up button. I love thumbs ups. Of course, if you didn't like it, I don't really like thumbs downs, but you can do it. Just be honest. Okay, thank you for watching. See you at howtodostuffwithethan.com. DoStuffWithEthan.com, howtodostuffwithethan.com, and see you next time. Bye.